Okay, so let's talk about something we all feel every single day, but maybe don't really think about. Heat. From the sun's rays hitting your face to the steam coming off your morning coffee, heat is just constantly on the move. But how does it actually travel? What are the invisible highways it uses to get from a fire to your fingertips? Well, it's not magic, it's physics, and it's one of the most fundamental stories in the entire universe.
Come on, we've all done it, right? You're cooking, you're not paying attention, you go to grab the handle, and ow! That sharp, searing pain is a perfect and, yeah, pretty painful reminder of these invisible forces of heat transfer. So, how on earth did the heat from that burner travel all the way up the handle to get your hand?
Well, the answer is right here in this simple picture of a pot of water on a stove. This one, everyday scenario, holds the secret to how heat gets around. It's basically a three-part story, a kind of secret recipe with three key ingredients. We're going to break them all down: radiation, conduction, and convection. First up, the heat has to make this big leap from the source to the pot. This first part of the journey involves a process so powerful it can cross the huge, cold emptiness of space or just the tiny gap between your stove and your pan. This, my friends, is radiation. So look, the burner isn't physically touching the pan, but it's beaming out these waves of energy, almost like a tiny little sun right there in your kitchen. Those wavy lines you see in the diagram, that's the energy jumping across the gap, an invisible bridge made of pure heat. So what is radiation exactly? It's just heat traveling as pure energy waves. Think about the sun. It's millions of miles away, across the total vacuum of space. Yet we feel its warmth on our skin. That's radiation, a direct transfer of energy through space, no strings attached. Now, here's the really wild part, the real aha moment. Radiation doesn't heat up the space it's traveling through, it only heats the object it hits. So the air between the stove and the pot, it's not getting hot. It's more like a focused beam of energy, kind of like a heat laser, delivering its payload directly to the bottom of the pot. All right, so the heat has successfully leaped to the pot using radiation. The bottom of the pan is now sizzling hot. But how does that heat spread from the bottom all the way up to the handle? This is where our second mode, conduction, takes over. That heat energy, it doesn't just sit at the bottom. It starts to climb, marching right through the solid metal of the pan itself. From the base, up the sides, and right along that handle, just waiting for your unsuspecting hand. Conduction is all about direct contact. So imagine the molecules in that metal pan are like a super tightly packed line of dominoes. When you heat up one end, the first molecule starts vibrating like crazy. It bumps into its neighbor, which then starts vibrating, and that creates a chain reaction that passes the energy right on down the line. And here's the crucial difference to keep in mind. With conduction, the molecules themselves don't go anywhere. They just vibrate in place and pass that energy along. This is why you need a solid material, a medium, for it to happen. Metals are fantastic at this, which is exactly why we call them thermal conductors.
So, the pan is hot, the handle's getting dangerously hot, but what about the water inside? How do we heat up the whole pot of water, not just the little layer at the very bottom? For that, we need our third and final hero of heat transfer, convection.
See those swirling arrows inside the pot? They represent this powerful, circulating current that is actively mixing and spreading the heat all through the liquid. This is convection in action, and it's pretty cool to see. So unlike conduction, where particles just vibrate in place, convection is all about the actual movement of hot particles. Hotter, energized particles physically travel from one place to another, and they carry their heat with them, kind of like a delivery service. This can only happen in fluids, so liquids and gases, where all the particles are free to move around. So here's how that cycle gets going. The water at the bottom gets heated by the pan. As it heats up, it expands, becomes less dense, and then it shoots up to the top. This movement pushes the cooler, denser water that's at the top downwards to fill that empty space. Then that cool water gets heated and rises, creating this continuous circular flow, a convection current that very efficiently heats the entire pot of water. So, we've met our three heat transfer heroes. Now let's see how they team up, how they work together in this perfect harmony to do something as simple and yet as complex as boiling water. It really is a beautiful three-step dance. Radiation leaps from the stove to the pot. That's the opening move. Then conduction spreads that energy through the solid metal of the pot, a steady, constant rhythm. And finally, convection circulates that energy through the water inside, the grand finale. Each mode has its own special part to play in this choreography of heat. This chart really puts it all into perspective, doesn't it? So what's the big difference between them? Well, it all comes down to how the heat travels and whether it needs something to travel through. Radiation, it can cross the total void of empty space. Conduction, it needs the tight formation of a solid. And convection, it needs the freedom of a fluid, where particles can actually move around. And that's really the main takeaway. Heat transfer isn't a one-size-fits-all kind of deal. The universe has come up with these three distinct, incredibly efficient methods to move energy around, and each one is perfectly suited to the environment it's in. It's a really elegant solution to a fundamental challenge. Once you start looking for it, you'll see this trio absolutely everywhere. The sun warming your face? That's radiation. A hot coffee mug warming your hands? That's conduction. The way an oven or a room heater warms up the air? Convection. So as you go about your day-to-day, keep an eye out. Where else do you see these three powerful forces of heat at work? You might be surprised by just how often you find them.